My name is Chris Henry. I'm an assistant professor and water management engineer with the University of Arkansas. We're looking at irrigation water management practices and how to improve irrigation efficiency. In this experiment we have several treatments. Deep tillage, where we till the ground down to 18 inches to break up the hard pan. We're also looking at gypsum to see if we can improve the infiltration characteristics of the soil. And then woven over this, we have 4 different irrigation treatment levels: dryland, fully irrigated, and then 2 intermediates. So this study will help us improve our irrigation scheduling practices and technology, as well as that also allows us to look at how the interaction of different management practices affects irrigation. Well, the way we schedule irrigation on this trial is we use atmometers, or the ET gauge, as is commonly known, and we set different trigger levels. And these atmometers represent the 3 different trigger levels. Now, what an atmometer does is measure crop evapotranspiration. And we developed deficits, and this is our treatment 1 is our current recommendation, standard practice for triggering irrigation. And here's our deficit. And then we try to extend the deficit out a little bit further to see if we can go longer in between irrigations without having crop yield loss. And this is our highest deficit. And after this we would have dryland, non-irrigated. And so there is an interesting interaction between stretching irrigation out and tillage. For example, we've noticed that we don't have as much yield difference in this treatment as this treatment when we use deep tillage. So we have noticed about a 7 to 12 bushel yield difference between deep tillage and non-deep tillage without using deep tillage. Gypsum's a longer term experiment for us. It's going to take a couple years to develop that and get that treatment effect, but we're looking at that as well as the interaction of deep tillage and gypsum in this experiment. Again, why we're doing this experiment is so that we can figure out what this deficit needs to be so we don't have any yield loss. So we measure soil water with watermark sensors. We have a wireless node network out here in the plots, and I'm able to view it on my cell phone. I can look any time of day and see what the soil moisture profile is in this field, especially right before and right after we would make an irrigation decision. And then we use that information to make decisions about irrigation scheduling and whether these practices can help us improve irrigation efficiency and improve profitability. What we're doing here is giving the farmer information about how he's irrigating so he can make better decisions about when to irrigate. And if we know when we need to irrigate, if we're irrigating enough, or if we're over irrigating, then we can use just the amount of water that we need to irrigate. Surge valve improves efficiency. Computerized hole selection improves efficiency. The ET gauges and the watermark sensors help us get the most crop per drop, so we're not applying any more water than we need to. And if you do all those things, well, that's going to move you to be as sustainable as you can. On behalf of Leo Espinoza, Paul Francis, and myself, I'd like to thank the Arkansas Soybean Promotion Board, Arkansas farmers, and their checkoff for funding our research into irrigation and yield stability in soybeans.